So just a quick revision of what we are doing. We have started with the next unit, which is grammars. So as I told you that we are discussing about the different types of languages, and whenever there is the term language, grammar comes along. So grammars are basically the set of rules that are to be followed to form a particular sentence of the language, you can say. So to form the strings, to form the language, we need some rules. And those rules are termed as the grammar. And in formal language, we have four different types of grammars and four different types of languages that we were discussing. Then we saw the formal definition of language, of grammar, and we saw the tuples are, there are four tuples. So the tuples are the starting symbol from where the grammar is starting, the production rules, all the set of variables and all the set of terminals. Okay, so we have, and now coming to this, we also have these two types of symbols. So grammar can be classified into two symbols. One is the terminal symbols, another one is non-terminals. So non-terminals are basically the variables which are going to be replaced by the terminals. And terminal symbols actually form the sentences, the strings of the language. So this is what we have discussed till now. Then we saw that given any grammar, we can derive a string. And for the derivation process, we have three different methods. One is leftmost derivation, where you have to continuously replace the leftmost variable in any production, in any production where in the right hand side, the leftmost production in the right hand side, we have to keep on replacing it with whatever production is nearest to our string that we want to generate. Then we saw that similarly we can do the rightmost derivation. Then there is the third process, the third step for the derivation, which is your derivation tree. Derivation tree, also known as syntax tree, also known as parse tree. Okay, so this is again one more method to do the derivation. That means the question would be given in this way, that you have to derive the string. Yeah, so the question, in the question, the grammar would be given to you, and along with the grammar, the string would be given to you. So I'll write down the question and then we'll take. So let's say the question is given in this way. We have already taken it. I'm taking the same question. Okay. So this is our production rules that is given to us, and we have to generate the string A, B, B, and A. This is the string we want to generate. Now see, for a derivation tree, there is a root node. Root node would always be your start symbol. So root would be your start symbol. And the final, that is the leaf nodes, they would be your string. And what would be about the intermediate nodes? They would be the non-terminals. Intermediate nodes would be your non-terminals. Okay. So this is the thing that we have to follow to consider a derivation tree. Symbol leaf is the string and intermediate nodes are the non-terminals. So if I take this question and I have to generate this string, the only option you always have is to start with the start symbol, start symbol production basically. And this is the only thing that you have to follow. For leftmost derivation also, you'll have to start with the start symbol, for rightmost also, and even for the derivation tree. So how will I write? This is my start symbol, which is the root. Then I'll make all the productions in the form of the different nodes, the child nodes. A, and S. This is one production, right? Now I have to generate a string like this. Now you can either replace this or you can start replacing this. There is no order for left or right. Okay, we just have to make a tree. So I'll replace this A with SB A. We have already done this. You have to just represent it with the help of a tree. B and then A. Now I have to replace this S. So I can replace this S directly with A. So AAB is generated. Now I want BAA, right? So for BAA, I can replace this A with B A, and now only one single A is left, so I'll replace this with A. So now if you see all the leaf nodes, they form the string. Yes, the leaf nodes form the string in a sequence A, This is what the string that I wanted. So this is how is your derivation tree. The process actually is similar in all the three, that is leftmost, rightmost and derivation tree. It's just that you have to, the representation is different, you can say. Leftmost may we are continuously replacing the leftmost variable, rightmost we are replacing, and derivation tree may we representing it with the form of a tree. Make a note of it and then we'll take further. Okay, so now next we are going to take, you can do one more question that we have taken for the leftmost and the rightmost derivation. Later on you can do the practice with the derivation tree. I'm not taking it much ahead. Okay, so now we are going to take the rules for your different types of grammar that we have studied till now. So what are the types of grammar that we have studied till now? There are four types, right? Type 0, type 1, type 2, type 3. So I'm going to make you write all the rules or the restrictions of the grammar. So if the question comes in this way, that you have to mention Chomsky's hierarchy. Yes, so Chomsky's hierarchy you have to mention. Then you have to make the diagram. Have I made you, have I told you that diagram? Right, I think so. We have already discussed that.
Ma'am, the hierarchy of diagrams is done as in the automatas, the grammars, and the language.
Yeah, okay. Take it. So you have to make those three diagrams whenever this Chomsky's hierarchy is asked, and then you have to write all the restrictions of the grammar. So today I'll make you write all the restrictions of the grammar so you can just start writing it. The first one we'll take is the unrestricted grammar. Unrestricted grammar. Also known as type 0 grammar. So for MCQs, directly they can ask what is type 2 0 grammar, type 1 grammar, what is type 2 grammar. So you should know all the codes. So this, it actually starts from here 0, 1, 2, 3. You can remember it in the picture form, you'll never forget. Okay, unrestricted grammar, recursively enumerable grammar, type 0 grammar, they are all used for this first type 0. So here you write down there are no restrictions on the production of a grammar of this type. There is or there are no restrictions on the production of a grammar of this type. This type of grammar, yes,
There are no restriction in production of a grammar, right?
yeah, production of a grammar of this type, that is type 0. Of type 0 you can write. There are no restrictions on the productions of a grammar of type 0. Next you write down, this type of grammar permits the production of the form. This type of grammar permits productions of the form, permits production of the form. Alpha tends to beta or alpha produces beta. This type of grammar permits production of the form. Alpha derives beta such that alpha should never be epsilon, such that alpha is never be epsilon, and alpha comma beta is a subset of variable or terminal, so nothing. So these two conditions are to be fulfilled. We have already written this in the grammar definition, so now you can just identify that the unrestricted grammar form we have written. Yeah, so it could be anything of the variable or the terminal, or it could be nothing, but then alpha specifically should never be nothing, because see, it makes sense, right? You are writing epsilon deriving any terminal, not possible, no, not possible. So alpha can never be epsilon. Beta can be epsilon. Some grammar producing nothing. So that is possible, but the reverse is not true. Okay.
And subset of terminals and
Variables, non-terminals, terminals and non-terminals. This is union, huh? This is union. V union T.
Ma'am, can you repeat the second sentence again from the start?
Yes. Yeah. So this type of grammar permits production of the form. This type of grammar permits productions of the form alpha derives beta such that alpha can never be epsilon. You can just write these statements A and B such that A alpha not equals to epsilon and B alpha beta are basically variables union terminals. It could be variables, it could be terminals.
Ma'am, since we put that closure sign after variables union terminals,
Yes.
it can be neither two, right?
It can be null, but then specifically at the same time, this is also written. That means it
Yeah.
says beta can be null, but alpha can never be null.
Okay.
Okay, you can write the language formed by this grammar. The language formed by this grammar is known as recursively enumerable language. The language formed by this grammar is known as recursively enumerable language. Which are recognizable, or you can say which are recognized by a Turing machine. Which are recognized by a Turing machine. Okay, so example also now we'll write one example. See, these type of languages are what? These type of grammars, I'll just write the example of a grammar. There is no restriction. It just says that alpha cannot be epsilon. And that makes sense. That is not a restriction. That makes sense. The epsilon deriving anything. Not possible. So that makes sense. Apart from that, it could be anything. So it could be in this form. Let's say A tends to AB. AB tends to BC. Okay, even like this, it is possible. This C, small c is a terminal. Okay, I'll write instead of C, I'll use another thing. Let's say A1 generating 1, 2, 3. Okay, even like this 1A2 generating 3, 4, something like this. So I'll write all the variables are A, capital A, B, C, and the terminals that I have is 1, 2, 3, 4. Okay, so this is one example that you can write it down. So you can see there are no restrictions here. Yes, when we'll see the ahead questions, it will be more clear. Okay, next write down the second one, that is type 1, which is your context sensitive. Context sensitive grammar, which is also your type 1. Type 1 grammar. Okay, the first restriction that comes along here is that write down for each production of the form, alpha produces beta. For each production of the form, alpha produces beta. The length of beta should be at least as much as length of alpha. The length of beta should be at least as much as the length of alpha.
Ma'am, could you repeat from the start?
Yes. For each production of the form, alpha generates beta. Write down the equation that I have written, that is alpha generates beta. Write it down. The length of beta is at least as much as the length of alpha. Should be at least as much as the length of alpha, except for this thing. That means except for this. That means there could be a production where A non-terminal is generating epsilon. So epsilon is actually considered as length what? 0. So length 0 is less than s because the left hand side is having a terminal. Only except for this where it is only epsilon, apart from that it says that beta ka length should always be equals to or greater than the length of alpha. That means whatever number of elements you have in your left hand side, the right hand side variables or the non-terminals together should be more than that of the left hand side. In simple terms, right hand side mein the count of the variables non-terminals should be greater than the count of the variables or the terminal symbols of compared to the left hand side. Okay, now write down next restriction here. The rule S tends to epsilon, the rule S tends to epsilon is allowed only if the start symbol S does not appear, only if the start symbol capital S does not appear on the right hand side of any production, on the right hand side of any production. I repeat the whole B restriction. The rule S produces epsilon is allowed only if the start symbol capital S does not appear on the right hand side of any production. Does not appear on the right hand side of any production.
Ma'am, sorry, what symbol was it?
Symbol epsilon. Only if the start symbol, okay. Only if the
Okay.
start symbol S does not appear on the right hand side of any production. What does this mean? Suppose there is this start symbol S tends to A and epsilon. That means there is a production that S is generating epsilon, and now let's say I'm producing something like this. This complete grammar is not allowed. Why it is not allowed? Because it is saying start symbol should not be there in the right hand side if there is a production x tends to epsilon. Is it clear? So this is not allowed. You can write it down, but then you can write it as a cross that it is not allowed. It's a wrong example because it is violating the second restriction. Okay, the C part. Now write down the C part. The term context sensitive is used. The term
Ma'am, I'm
context,
sorry, I have a doubt.
yeah, tell me.
So S also can't have A on the right hand side, and A also can't have S on the right hand side. Am I right? Or only for one the S?
There is no restrictions with A and S. It just says that if there is a production, S tends to epsilon. There are two productions of S, right? The slash means there are two separate productions of S. One is S tends to A and one is S tends to epsilon, right?
Yes, ma'am.
Slash means two separate productions there. So it says that if in the grammar there is a production as S tends to epsilon, then this S, that is the start symbol, cannot appear in any of the right hand side production. But the second production, if we see of the grammar, the right hand side consists this S. So S on the right hand side and S tends to epsilon together are not possible for a particular grammar.
Understood. Thank you.
Got it? Okay. Now next write down the term context sensitive is used. The term context sensitive is used because the grammar has productions of the form, because the grammar has productions of the form like this. I'm writing it down, you write it, you just copy it. Alpha 1, capital A, alpha 2 produces alpha 1 beta alpha 2 such that beta cannot be epsilon.
Ma'am, can you repeat the entire thing again?
Yes. The term context sensitive is used because the grammar has the production of the form that is written. I have written this thing, you can just write it down. Because the grammar has the production of the form alpha 1 capital A alpha 2 produces alpha 1 beta alpha 2 such that beta cannot be epsilon. Now next write down alpha 1 and alpha 2 may or may not be empty. Write it down. Alpha 1 and alpha 2 may or may not be empty. It could be empty also. That means there are no variables or terminals there. Or it could be that they are empty and only a single terminal symbol is there in the left hand side. But at the same time, the restriction says that the right hand side variables or the non variables or the terminals length should be greater than that of the left hand side. Okay, write down the D point. Context sensitive grammar generates, or you can say, you can write it in short, type 1 grammar generates context sensitive language which are recognized by linear bounded automata, which are recognized by linear bounded automata.
Ma'am, can you repeat the last sentence?
Yes. Context type 1 grammar. Do not write context. Write down type 1 grammar generates context sensitive language. Type 1 grammar generates context sensitive language which are recognized by linear bounded automata, LBA. Linear bounded automata. Write it down.
Ma'am, in the C point, alpha 1, alpha 2 may or may not be
Epsilon. Empty. May or may not be empty. Epsilon, anything you can write. Okay. I'll give an example and then I'll explain all the points that I've made you write. So basically it is saying that context sensitive grammar could be of this form. Let's say I'll generate a grammar, then I'll write the definition. A tends to AB. Possible? Is this possible? Right hand side where their length is 2, left hand side where it is 1. Yes, it is possible. The least possible should be like this. B tends to, let's say, small a. This is also possible because the right hand side is equal to what is there in the left hand side. So this is also possible. Okay, and it could also be of this type. A tends to AB. A, let's say. Yeah, this is also possible. Even it could be like this. AAB generating B, something like this. This is also possible. Are you getting where is the restriction? The restriction says the main restriction is of context sensitive grammar says that the right hand side symbols should be greater, equals to or greater than the left hand side symbols. And it says that if the start symbol is generating epsilon, then there should not be this start symbol anywhere in the right hand side production, but it is there 2 times. So this production then is never possible. Okay. So these are just the 2 types. And this form means what? See, alpha 1 and alpha 2. Alpha 1 and alpha 2 are nothing. It is just saying that there could be terminals, there could be non-terminals in front and in back. Possible, not a problem. So the production like this is also possible. It could be empty. In this case, you can see this is empty. In this case, you can see both are empty. So this is possible. Just you have to make sure that the right hand side symbols should be more than the left hand side symbol. That is the major restriction that we have for your context sensitive grammar. Yes.
Could you explain again, because your cursor isn't moving, so it's difficult to know what you're talking about.
Okay, so I'm just saying, see the right hand side, when I draw that, so you can see, right?
Yeah, ma'am, we can see
Okay.
the draw.
Okay, so now see the right hand side, what is the count of the symbols in right hand side? It is 2. What is the count of left hand side? It is 1. So it is just saying that the count of the symbols in the right hand side of the production should be greater than that of the left hand side production. This right hand side should always be greater than that of the left hand side production. Greater as in what sense? Length, count of the symbols should be greater. The second point that I have made you write says that if the start symbol, now for this the start symbol is capital A. The start symbol saying is capital A. Okay. So the capital A, if it is generating a production as capital A tends to epsilon, then it says that capital A should never exist in the right hand side production. But if you see in the first production as well as in the third production, capital A is a part of the right hand side. So a production A tends to epsilon is not possible. Are you getting the point? Yes, it is clear.
Yes.
Okay, so if you remember these 2 restrictions, it's enough. This form just is a description that there could be before and after, there could be terminals, non-terminals. A production like this is also possible. Let's say like this. Okay, so here the variables are capital A, capital B, capital C, and the terminals are small a, small b, small c.
Ma'am, all these are allowed, right? Whatever you have written in example.
Yeah. All of them are allowed. All of them are allowed. So you can just write down the example. And then we'll move to type 2 grammar. See type 1 grammar, since it is in the hierarchy, it is the next, and it is a less restrictive compared to what? The unrestricted grammar, which is type 0. So even context sensitive grammar can be recognized by a Turing machine. Along with linear bounded automata, Turing machine can also recognize type 1 grammar or type 1 languages. But specifically mentioned, you have to remember कि regular grammar के लिए what is the automata used? Finite automata. Though at the same time I'm saying a regular language can be identified by any of the automatas that are available, because all the automatas apart from finite automata are higher in the order. They have more power in the way they have a data structure that can remember or count, store the elements. We'll see that the higher automatas have more power. We'll see it later on. But right now, you have to remember that regular grammar ke liye the automata available is finite automata. So in question, if it is asked, what type of automata is or recognized by a regular languages? A regular language is recognized by what type of automata? So in the option, if all the 4 automatas are given, you have to select finite automata. Though I do agree that even a Turing machine can recognize a regular language, but what is the least automata that can recognize it? Okay, or what is the associated automata that can recognize a regular language? So you have to remember it in this way. That's why I have made you write linear bounded automata for context sensitive grammar. But I'm telling you that even a Turing machine, you should know this thing, that a Turing machine can solve languages of this restriction, that is type 1 grammar. Okay, have you made a note of this? Can we move ahead now? Let me know when you're done. Yes, can we move ahead?
Yes, ma'am.
Yes, ma'am.
Next, you write down type 2 grammar, context free grammar. The third one that we have is context free grammar, which is your type 2 grammar. Okay. Now write down the only allowed type of production is, the only allowed type of production is A, capital A tends to alpha. Capital A generates alpha. The only allowed type of production is capital A generating alpha, where A is a non-terminal. Write down, A is a non-terminal variable, or you can say non-terminal, where A is a non-terminal and alpha is of the form variable or variable union terminal closure. That means it could be, alpha could be anything, either a variable or a terminal or a combination of variable terminal or even epsilon, because it is star. Okay, so alpha could be anything. The
Ma'am, can you
only
repeat from the
restriction,
start?
okay, the only allowed type of production is, the only allowed type of production is capital A tends to alpha. Written on the board, capital A tends to alpha, where capital A is a variable or a non-terminal. Strictly capital A is a variable or a non-terminal, and alpha, which is on the right hand side, it could be anything, a variable, a terminal, or anything. So you just write these two things. That would be enough. Instead of writing it in words, you can write these two statements. Write this form and write these two statements. B part, write down. The left hand side of the production, the left hand side of the production, left hand side of the production contains only one non-terminal. Only one non-terminal. Very important. Only one non-terminal. And in this point only you can write down start symbol can be there in the right hand side. Start symbol can be there in right hand side. Okay, start symbol can be there in the right hand side. So what does the restriction says कि कोई भी production होगा in that particular grammar, the left hand side will only consist of one non-terminal. Right hand side can be anything, but left hand side strictly one non-terminal. I'll write. Okay, next point, write down.
Ma'am, could you repeat the B point?
B part I've written, no? Left hand side consists of only one non-terminal and the start symbol can there be in right hand side. Okay, write down the language generated is context free language. The language generated is context free language. The language generated is context free language recognized by push down automata. After the grammar unit, we are actually going to start with this automata, which is our push down automata. So context free languages are recognized by push down automata. Last में we'll write the example. I'll write.
Excuse me, ma'am,
Yeah.
but can you repeat on the part that if something is given, like all four automata is given, and we are asked like what is recognized by
Okay.
CFL? So
Yes.
we need
Yes.
to mention just push down automata or all, because all are
No.
recognized, right? Since the
Yes. All.
hierarchy is so.
All the above in the hierarchy, that is a linear bounded automata or Turing machine, they can recognize a context free language, but the least possible, that means the least powerful that can solve or that can recognize a context free language is a push down automata, right? So you have to mention push down automata only if asked for.
Okay, so when if asked, we have to mention only the same level ones, right?
Yeah, the same level ones,
Okay,
exactly.
okay, thank you.
So the production is in this form. This is the example of a context-free grammar. So see, left-hand side only have one production, which is capital S. Right-hand side, no restriction. Even a non-terminal terminal ka combination, a single non-terminal, epsilon, anything is allowed. No restriction on the length, no restriction on any other thing. It just says that left-hand side pay there is a restriction and it should be strictly one. Okay. Next, write down regular grammar, type 3 grammar, regular grammar. The last one that we have is a type grammar, regular grammar. Yeah. Okay. Now write down this type of grammar. These type of grammar has the productions has the following restrictions. These type of grammar has the following restriction. A part, left hand side of each production, left hand side of each production should consist of one non-terminal. Should contain only one non-terminal. Okay, so this restriction is that of which we had in our type 2 also. The left hand side strictly should be just one non-terminal. So the same comes here, that the left hand side is this. Now in this grammar, since it's the most restrictive one, so we also have a restriction in the right hand side. So what does the restriction says? Write down the B part. Right hand side contains, or you can say right hand side can contain, right hand side can contain at most one non-terminal, at most one non-terminal symbol. That means there could be no non-terminal symbol, but if there is a non-terminal symbol, it has to be just one non-terminal symbol which is allowed to appear, which is allowed to appear as the rightmost symbol or the leftmost symbol, which is allowed to appear either as the rightmost symbol or the leftmost symbol. Okay, so here right hand side can contain at most one non-terminal symbol which is allowed to appear as the rightmost symbol or leftmost symbol. I'll make you write it down also, the example, and then it will be more clear. I'll explain you. C part, you can just write it down on your own, that languages are regular languages. Languages generated are regular languages and they are recognized by finite state automata or finite state machine. Okay. Now see, write it down. In the example, you write it down that basically, since as I told you, either it could be rightmost symbol or leftmost symbol, right? The variable in the right hand side could either be the rightmost or the leftmost. So on the basis of this, it is actually categorized into two further type of grammar. So you can just make it down somewhere that a regular grammar is further classified as a left linear grammar and a right linear grammar. The right में क्या होगा? The variable in the right hand side will be at the rightmost. And in left linear grammar, the variable on the right hand side will be at the leftmost. And there could be only one non-terminal in the right hand side. At most it is written. I'm not going to say only one, because only one says that right hand side may not, like it will always have to have one non-terminal. That is not the restriction. If you see the second production, it is only generating a terminal symbol, right, which is 1. It is only generating a terminal symbol. So that is not necessary. What is necessary is that it generates it has to have at most one non-terminal. It has to have one non-terminal. Yes? Is it clear now to all of you? If you want more example, I can give it. So in left linear grammar, it could be like this. This is example number 1. 2 में if I'm going to increase, let's say CA, BB, then C generates capital B, small b, capital V generates capital B, A, B. One important thing that is to be noticed here is that all the productions, if it is a left linear grammar, all the productions should be of left linear type. That means that the variables all should be at the leftmost. ऐसा नहीं है, there should never be a grammar like this. Let's say S generating CA and then C generating B capital B. This is not possible because this is showing what? Left linear, left hand side पे capital C is there, and this is showing right linear, capital B is there. So this together is not possible. This together becomes a higher order grammar, which is your context free grammar. But if only all the symbols are at the, see, all the variables here are at the left hand side. Here all the variables are there in the right hand side. I'll take one more example here. Right? See here all the symbols are on the right hand side. So that type of a grammar is a right linear grammar. Is it clear to all of you now? Just write down the examples. Sorry. Also make this. Okay. So now we'll take the next type, which is formation of the languages and the grammar. So the next topic that we have. Okay, so I'll start with the very basic and then slowly we'll increase the complexity. So here, let's say a grammar is given to you. First, we'll make the language set because that's the easier part, and then we'll form the grammar. So let's say a grammar is given to you. Write down the question, note down the number so that I know how many we have done. So from here, let G be a context-free grammar, which is defined as let G be a context-free grammar, which is defined as capital S produces small a, capital S, small b, slash AB. Okay, so you have to find the context free language for the grammar. This you have to find. So what you have to do is we have to just derive. Okay, so see, S derives AB. It is direct. It is direct, right? Apart from that, what else different? I'm just going to write the language set here. So smallest string possible would be AB. Next, it could be I can take the other string which is ASB, and then this S I can replace it with AB. Right? This S I have replaced it with AB. So the next string possible would be AABB. Then again, I'll take ASB. This S, this time I'm going to replace it with ASB. And then this B is there. Now this S I'm going to replace it, let's say, with AB. So it is triple A, triple B. And so on. At least 3 to 4 strings you generate. And then since it is going to keep on going, right? It is infinite. It is infinite and it is going to be of this type. Yes, is it clear? The language formation is clear to you all. We are just deriving the different types of strings possible and you just make the language set. This is the answer. Yes, is it clear to all of you?
Ma'am, how did ASB become AASBB?
This part you are saying? I
Yes,
have
ma'am.
just replaced the S with the first production ASB. Instead of the second production which is directly AB, which I did it here, this time I have replaced it with ASB, the first production. I can keep on replace this S with any of the production, right? Both are S productions. Agreed? Is it clear?
Yes, ma'am.
Okay. You can actually generalize this also. See, the number of A and number of B are always going to be same, right? Even if next time instead of this AB, you generate again it with ASB. So it is equal number of A and equal number of B. So I can just write it like this, A and B, where N is greater than equals to 1. This is the language. You can generalize it. This is optional. If you identify it, you can generalize it. Number of A followed by number of B. Okay, now let's take a bit complex one for this language generation. The second question again says you have to find out the context pre-language and the grammar given to you is of this form. Capital S tends to A, B, B, A. capital A tends to A, capital S, B, A. And capital B tends to B, B, S, A, B. Okay, basically if I write it separately, there are many productions. Huh? It is AB and S tends to B, A tends to A, then A tends to A, capital S, then A tends to B, A. Also, capital B के भी there are three productions. B, capital B tends to small b, S, capital B tends to A, B. So how many productions are there? There are 6, 7, 8. 8 productions are there. These are the 8 productions. You have to form the language set. You have to generate the language set. You can number it so that you can just write with what production I'm going to replace. It would be easier for you also to understand. You just number it. Okay, let's start. We'll always have to start with the start symbol, right? So I'm going to take this S derives AB. Yeah, and we'll start with the smallest one of B. So by sixth rule, I'm going to replace this B with small b. So it is AB. Keep on writing here. So the generated string have AB. Right. Now let's take the other one. S tends to B capital A. And I'll replace this A with small a. That is by rule 3. So it is BA. So the next string that is generated is BA. Yeah. Which one to take now? Any you can take. There is no order for that. Again, let's take AB. And this time, instead of replacing it with small b, let's replace it with BS. So I'm going to replace it with B capital S. Again, S I have to replace, right? So let's say I replace S with 1. So I'll take A capital B. Let's replace this B now with 6 to generate the string. It is AB. So I'll write it as AB. Okay, next again. S deriving. Which one to take now? Anything you take. I'll take B, B capital A. Now this time capital A, I'll replace it with 4, which says BAS. S I'm going to replace it with, let's say the second one, that is BA. Second one says B capital A. Now this capital A I'm going to write it as small a. It is BABA. Yes. With so many strings generated, 4 to 5 you can generate. Since there are so many productions, at least try all the productions once. Yeah. So I'll take this time, let's say A capital B, that is first one. And now this capital B, I'm going to replace it with A capital B. And this B, I can replace it with small b's. It is A. So, can you generalize it now? You just try more strings. Do not stop here. Try more strings because some of the productions are still remaining. B capital A. So capital A, I'm going to replace it with the fifth one now. So it is B capital A. I'm replacing it with BAA. And this AA, I can replace it with small a. So it is also having a string like this, BBAA. Can you generalize it to something with all the strings
Equal
that are?
number of A's and B's.
Very good. So it is equal number of A and B, but there is no order. So I cannot write it as A and B and, but you can generalize the language and you can say that the language, just a second, Generalize the language and you can say containing equal number of A's and B's. Language containing, sorry, equal number of A's and B's. Yeah, this is the language. Okay, so you can get questions like this where the grammar would be
Ma'am,
given to you. Yeah.
but for example, in the one in which the fifth one, where A is B A A, what if we change the all the capital A with the smaller a from the
You
rule
can
3?
never start with this. You'll always have to start with what? The start symbol. Always. And whenever
Ma'am,
you
but
start with the
we
start symbol, haha.
when should we use that A? Like when will we reach that A then?
Yeah, that we have used. No, here I have used. See, start symbol mein it is BA. I have started with the start symbol and then this time the A I have replaced it with B triple A. B double A. Yeah, this one, fifth one.
Got it, ma'am.
So this you have to make sure for even all the three derivation process that we have done. This is nothing but the derivation only we are doing, right? This is the derivation we are doing. So every time you will have to start with the start symbol. Okay, now we'll take the second part of our topic, which is generation of a grammar. Now, this is a bit tricky. So I'll start with the very basic. Let's form the foundation first, and then we can take a bit more complex questions. Okay, so I'll write the first very simplest one. Write down, write the grammar for, write the grammar for the language a raised to the power n such that n is greater than equals to 0. Such that n is greater than equals to 0. So basically what type of language set it is? It is going to be greater than equals to 0, right? So epsilon would also be a part. Agreed? This is the language. Now how can I form
Yes,
the
ma'am.
grammar? Right? How can I form the grammar? Say the start symbol, we'll always have to start with the start symbol. And the start symbol need not be S every time. There could be grammar where the start symbol is A. So it would be mentioned to you. But if it is not mentioned anywhere and you are forming the grammar, I would suggest you always start with the S as the start symbol. But again, I'm saying this is not necessary. Capital S tends to see whenever epsilon is a part of the language, no start symbol will have to generate epsilon because apart from that, there is no possibility of generating the epsilon. So whenever language set is going to have epsilon, start symbol is going to generate epsilon. Now I have to generate this. Number of A's are continuously repeating and the smallest possible is A. But if I write it just A, will it be possible? Because S has derived A. Next time again it has to derive another A. Next time let's say there are 3A. So it is continuously getting repeated. So I can write it like this. Because the start symbol is continuously repeating. If it is single A, let's say it is single A, I can take this production AS and this S I can replace it with epsilon. So it would generate A. If I want to generate double A, I can take it AS. Again, I can replace it with AS and this time S I am going to replace it with epsilon. So it would be double A generated. Are you getting the point? Is it clear to all of you? Absolutely clear, is it?
Yes, ma'am.
Okay, and please try
Yes,
to
ma'am.
avoid epsilon, writing epsilon at the start. So basically, you're going to write it like this. This should be your final.
Ma'am, do we have to show the simulation or the working?
See, Roshan, anyways, you will have to do the simulation or the working. Otherwise, you won't be able to form the grammar. So it is always a good practice that you show the simulation somewhere. Because anyways, even in rough, you will have to do it to form the grammar. So why not do it in the fair? So do it there,
Yes.
and then you can form the grammar. Just make sure you write it in here. Now you can also form it in this way. Huh? This is also equal. This also means the same. So your answer could be any of them, this or this. So if I talk about, this is actually my right linear grammar and this is left linear grammar, and I know this is a regular language. Are you getting the points now? Are you able to relate everything? Is it clear or not? If you don't say, then I will understand that it is not clear.
Ma'am,
And
Yes,
if,
ma'am, it's clear.
okay, ठीक. Do not write both the things. और लिखा है तो मतलब like you can write both of them. You should write both of them, but then write or, because in exam only one of them is required. Chalo, next, let's take next. So why I'm taking the very basic ones, because something, these kind of grammar is going to repeat. There are going to be more complex of the similar type. तो आप उस time पे कैसे directly solve कर सकते हो? Okay, so now let's increase the complexity a bit. And now if I say you have to write down, just give me 1 minute. Okay. Now you have to write down the grammar for the language or the regular. Now this time a regular expression is given to you in the form of a plus b star. ठीक है, अभी regular expression दे रखा आपको a plus b star. Now you very first thing is you have to generate the regular language, right? I'm going to
ma'am, I think this is
generate.
question 4.
Okay, sorry. So now I'm going to write the language set. What is going to be the set? Epsilon, A, B, it could be EB, it could be BA, it could be AB, anything, right? This is the language set. Now see, only A I have generated. So this is nothing but A and B ka combination, right? So this type of grammar is basically written like this. You always mention it in this way, huh? This is the grammar set. So G is start symbol generating C. Epsilon is going to be there because epsilon is there. The start symbol will have epsilon. Will have. It is mandatory. Otherwise, there is no possibility. अगर आप epsilon नहीं लिखते हो, then you are able to generate this. No possibility. So this so you'll have to write. Next, it can start with A. So I can write it as A capital S. And there could be B also. So I can write it as B capital S. So let's say I want to generate this string. Will I be able to generate? Let's see. Capital S deriving AS because it is starting with A, right? So I'm going to take AS. Now this AS, I can replace it with BS. Now this S, next time I can generate it with AS. Just a second. Now this S, I can generate it with BS. And this is epsilon. So the string generated is ABAB. So by practice, some of the strings, some of the grammar, you will just be able to identify just by looking at it. So now you know that whenever only a single character is repeating, only A is repeating, we are going to write it as AS. This means something is repeating, recursive, because the same symbol I have used in my right hand side production. And along with the one that is getting repeated, along with the terminal that is getting repeated. Epsilon wala concept I've already told you. Now here, A is also getting repeated and B is also getting repeated. So A ke saath bhi I have written capital S, B ke saath bhi I have written capital R. And since both of them are the production of this capital S, so even a combination where combination of A and B is also possible. Because you'll also have strings which are only having A. You'll also have strings which are only having B. So that is also satisfied here. And epsilon will always be there because it is there in the language set. It has to be there. Yes, is it clear?
Yes, ma'am.
Okay. Write it down, then we'll take the other one. Okay. Now इसको थोड़ा सा और complicate करेंगे. So we'll take a regular expression of this form. A plus B, A plus B, A plus B star. This is a regular expression. This is a regular expression for what? What is the language? Can anybody tell me?
It can be A, B, and then any combination of A and B after that. Like A or B, and then again A or B, and then a combination of A's and B's,
So if I
whichever.
generalize it, isn't it the length of the string should be at least 2, right?
Yes.
Okay. So now I'm going to take it as A, B, or let's say A, B, B, and then there could be 3 length strings also. Infinite. Epsilon, now you can see it is not a part. It is not a part. So start symbol may not consist epsilon now for this case. Acha dekho, abhi is for a question like this, how am I going to do it? The simplest way I'm going to tell you. You know this, you know the grammar for A plus B star, right? So you just write the grammar for A plus B star. Kisi or production. So start symbol is not going to be that, obviously. But there is a production of this AB star, which I know. So can I write this thing as this? This B, capital B, is representing this A plus B star. It is actually representing A plus B star. You all agree with this? This we just
Yes.
now did this, right? Just I'm not writing the start symbol because this is not the only production. This is not the only language that I have. Next, I have these two, and they both are similar. So can I write it like this? Either A or B. Right? So it's very simple. You don't have to form anything because it is either A or B. So I have written it as A or B. Now your start symbol, how you're going to write, see, there are two of A type, one of B type. Just write it together. That's it. Is it clear?
Yes.
So, okay. So if you know the separate part, the separate regular, see, it is easier if the regular expression is given to you. Suppose अभी language दिया होता आपको, then you would have formed this language set. तो थोड़ा सा उसको आपको मतलब you would have मतलब थोड़ा सोचना पड़ता. But then with practice, I'm sure you'll be able to know that. So you just separate it out, and then the start symbol you write all the non-terminals, and separately you write the productions. Okay, so similar type, let's do this one now. You do it. The regular expression is given in this way. You try this one. If you have not noted the first one, note that also and then try this one.
Ma'am, could the answer be small a, capital A, and then B for the S, the starting symbol?
Okay, and capital A
And
tends to?
A tends to the same, the A slash B A slash epsilon.
Very good, very good. This is the final grammar. Okay, let's take a similar type with a bit variation just for practice. You'll be able to know that. Language, again, a regular expression is going to be given to you. It says A plus B star B, this thing only, plus there is one more thing, which is B, A plus B star A.
Ma'am, so should we just add a slash after that A B slash B A? Like I'm not sure, but
Yes, this is correct. Absolutely correct. Because it is see the same type only. It's just that AB star is repeating same. Even if it is B plus A star, it is actually going to be the same, right? So I have kept it as capital A. It's just that these terminal symbols have interchanged. Okay, make a note of all these and then we'll take another question. Okay, next write down. Write a grammar for the language over A comma B. Now this time it is not given in the form of regular expression. It is given in the form of a language, right? Write down. Write a grammar for the language over sigma equals to A comma B containing at least one occurrence of AA. You have to form the grammar. Write a grammar for the language over sigma equals to A comma B containing at least one occurrence of AA. You have to form the grammar. First, to form the language set. It would help you out. At least one occurrence of AA should be there. Is epsilon going to be a part of the language?
No, ma'am.
so
Yes. It is AA, it could be BAA, it could be AAA, it could be BAAB or AAB, something like this. So
Ma'am, it can be only A also, na?
it could be
Only A.
no, at least one occurrence of AA.
Okay.
ma'am, could I try?
Yeah, please.
So in this, it's B will be AA slash BA slash epsilon.
Yes.
Then A will be AA,
Okay.
and S will be BAB.
So instead of making this A, you can directly write small a here also. Not a problem. Yeah, because there
Okay.
it is fixed, no AA. So you can write it like this also. So either
Yes, ma'am.
this,
As
or if
also,
somebody has written it like this, A, and A generating A, B,
and
B.
ma'am, can we have like a small A and capital A, and then
Just
or
a
we could
second,
have.
Roshan. Just a second, I'll complete this. So either this or this. Yeah, Roshan, tell me what you were saying.
So, like in the starting symbol itself, can we have two small a
This one, no? This you are saying.
and then capital A and or in the start?
In the start only I have written. See, capital
No,
A,
ma'am.
or
So like we can write it in this format as well, right? Like two small a and then capital A, then or symbol like the slash, and
mm-hmm.
then a and then a.
This means starting with A, ending with A. What
Yes,
if
ma'am.
I
But
have
it
B, A, A,
went
B?
okay. Okay. Yes.
Yes. So it is both the places, no? So if I form the regular expression for this, the regular expression would be of this form, right? AB star, AB star. So this is what we have done. So if you are thorough with this formation of regular expression, this topic would actually be easier for you all. Okay, let's take another one now. Sorry. Okay, if a regular expression is given in this way, then how will you form?
Ma'am, the language will have epsilon, right?
Yes, absolutely.
Ma'am, can I try? I'm not sure of this
Yeah,
one.
yeah, sure. No problem. Try.
A is epsilon slash B, and B is A slash B, and S will be A. That's it.
S will be A. Okay.
Yeah.
B is
B is A slash B. A
okay.
slash B. I think slash B also you can add capital B. One more. I'm not sure.
Okay. See, if you're writing this B, it is nothing but it is going to actually end there. Because see, B ko I am deriving as B, then I'll have to end it either with A or either with B. It is not going to repeat. This thing is only going to repeat only if you add some terminal here. Then it is, keep on, it is going to add something and it is going to be in a recursive way. This is actually going to stop only in the next step.
Understood, ma'am.
So this thing though is the same thing only. Doesn't make any difference. Okay, let me check. S I'm starting with A, okay? Then A can be B and B can be either A or B. Some mistake is there. See, A or B, you write either A or B. Anybody else?
Ma'am, what if we put A as BB instead of just B because it's twice of A plus B
Okay.
and add a epsilon, keep the epsilon anyways.
This epsilon is of A, right? And this you are putting it as A. Since the language has epsilon, directly can I make it like this? I can put this also as epsilon. This means the same thing. It is easier to understand because language itself has epsilon. So start symbol में epsilon डाल दो. Then you don't have to put epsilon with individual. That was also same thing only, not a problem. ठीक है. S tends to capital A tends to B and B is either A or B. But do you think this is fulfilling the star thing? Rest is fine. This is okay because this is what it is. This is B and this is B and A is the whole thing, right? But have I made you write A star like this? S tends to A, or let's A and then A tends to A like this. It is the star thing. Just think a bit modification is required, then this is correct. This is star. How I made you write the star? See, it is going to repeat, right? Repetition है किसी भी एक में तो can I write it like this? Do you all agree? See, if I do not write S, what happens? चलो करके देखते हैं. It would be more clear. See, S is deriving capital A. Okay, capital A is deriving this capital A. I'm going to write it as BB. And then this B I can write it as AB. ठीक है. Next time पे करोगे तो BA आ जाएगा. Next time पे करोगे तो let's say AA आ गया. Next time पे BB आ गया. That's it. What about this repetition thing? What if I need 4A? What if I need 4B? I have to keep on repeating this thing only, right? I have to put an S. If I put an S over here, next time I can also write it as AS. Are you getting the point?
Yes, ma'am, understood.
So whenever this star thing is, that's why I started with a very basic, that what does this star means? So star jab bhi aayega, there has to be this recursion thing. And then rest of the thing we have already discussed. So this thing is very much obvious. And this star, whenever star is there, this also should be obvious. Okay, it will come with practice, not a problem. You are doing good at the very start. Okay. Now next question, we'll take a bit different type. Now the language is of the form AN, BM, N and M are different, greater than equals to 1. So A raised to the power N, B raised to the power M, N and M are both greater than equals to 1. Right? So now here see what is the difference. AN I have already done. Correct? AN I have done. What was AN? And it is saying greater than equals to 1. That means at least 1 to hona hi hai. So I'm not going to write epsilon over here because epsilon karte what it would mean? It would mean that it could also be 0. And that is not the case. The smallest string possible would be AB. Right? So it is going to be A or either double A or either triple A and so on. B ko bhi I can write it like this. right? And what would be the start symbol? It is nothing but AB. Do you all agree with this? We have done
Yes.
A closure. It is just that A positive closure, B positive closure. So whenever the positive closure is there, instead of epsilon, you are going to write small a or small b or whatever is the terminal symbol. Now we'll take this one. अगर ये same question greater than equals to 0 होता, then the same thing would have been there, just epsilon आ जाएगा यहाँ पे. So I'm not taking that. Instead, I'm going to take the language is equal now, A and Bn. N is greater than equals to 1. We have done the question number 1, I think so. No, not, yeah, question number 1, where you had to, given the grammar was given to you and you had to form the language, right? It was of this type. So now you'll identify and you'll get why we have done it in that way. So it is A, S, B. Since it is greater than equals to 1, it is going to be AB. So equal number of A and equal number of B. So now one more concept I'll tell you with this. If you remember, I told you this type of a question, A and Bn, on basically this type of a language cannot be solved by finite automata. That means it is not a regular language, right? See, the grammar formed is a context-free grammar. इसके लिए जो grammar form हो रहा था, it was right linear, right? So that was a regular grammar. Here, the grammar A and B दोनों तरफ आ गया. It is not the rightmost or the leftmost. That means this is what? Context free grammar. I'm just making you understand the concept because I told you this is not a regular language. So the grammar is formed is also not regular. Okay, अगर इसी same question को हम ऐसे करें A and Bn where n is greater than equals to 0, then S tends to ASB epsilon. Okay, next question I'll take. Okay, पहले इसको different लेते हैं, then we'll take same. Such that n and m both are greater than equals to 1. Solve for this.
Ma'am, can I try?
Yeah, please.
So B would be CB slash epsilon, and sorry, not slash epsilon, not slash epsilon. CB. Then A would be AB slash AB.
AAB,
B
right?
slash
Slash
AB.
A.
Yeah,
Yes.
and S would be AB.
Very good. Very good. Absolutely right. Since this we have already solved, so you can do it together. This is C star, C positive closure basically. So that's why this is what we have written, and then this is just a combination of A and B. Very good. Now you have got the concept, what I wanted to explain. Very good. You can try 2 questions and you can try it later on. We'll stop for the day today. So you can try for
Ma'am, I
A.
actually was not sure with the epsilon thing, because what if A and then it's just epsilon, you take B as epsilon, then it's just no C's will be there. So M won't be greater than equal to 1.
No, it says n is greater than 1 and C is also greater than 1. That means the least string possible would be ABC.
Yeah, ma'am, but what if like we directly take B as epsilon? That's why I'm not sure with the epsilon.
C as epsilon. How can I take C as epsilon? Because M is also greater than 1, no?
No, ma'am, B as epsilon. So A and B, right? So
B को
B
भी
is
कैसे
direct
लोगे epsilon? B also is n, no? And n is greater than 1.
right. So right, got it. So
No,
it was
so you
right.
cannot take this is equal. तभी तो इसका हमने साथ में लिखा. Let's say all three were equal. Sorry, all three were not equal. Then आपको तीनों को अलग लिखना ही पड़ेगा. And if one of them is epsilon, then you can put that as epsilon. But the one of them is 0. Then you can write that as epsilon here. If all the three would have been separate, you would have to write all the three terms as separately. Yeah, you try for this one. And then you also try for AN, let's say CMBN. We'll discuss it in the next class. You try it yourself first. And one more I'll give. 3 questions you try. We'll discuss it in the Thursday's lecture, okay? You have to write it for this language, WW. Okay, we'll take WWR. That is palindrome. Palindrome strings. W is part of A comma B. W is A comma B. That means it is over A comma B and it is a palindrome kind of a string. It also includes epsilon in the language. That epsilon is a part of the language. And apart from that, it is a palindrome. So even single A, single B would be there. And rest, you try to find it out. Okay, these 3 questions you just note it down. Try to solve it yourself. We'll discuss it for sure.
Ma'am,
Okay.
what's the 15th question? It's WWR.
WWR, that means palindrome. And the strings are over A comma B. Okay. Yeah, I think so. All are present. See, many of you, at least 3 of you, so I know, have joined after 1 hour. So I'm going to give you, I did allow you in the lecture, but I'm going to give you one hour attendance. I have downloaded the attendance